In the age of mobile AI, uplink performance will define user experience. By 2030, uplink traffic is expected to increase five-fold, while ubiquitous 20 megabits per second becomes the new norm. However, the surge in users will drive heavier uplink load and stronger interference, significantly impacting uplink user experience. To tackle this challenge, Huawei has introduced Uplink Boosting. This solution intelligently optimizes uplink user experience across four domains: time, frequency, space, and power. Time domain adaptive MCS selection, accurate selection. The channel conditions of UEs are affected by various factors, including traffic volume and location. Traditional MCS selection methods often rely on historical scheduling information. However, sudden changes in traffic volume and location can lead to inaccurate MCS selection, degrading user experience. Huawei's Time Domain Adaptive MCS Selection algorithm for uplink boosting intelligently classifies UEs based on their traffic volume, as indicated by the packet size and measurement information, including RSRP and TA. Starting from initial scheduling and aiming for optimal spectral efficiency, the algorithm selects the optimal MCSs for different types of UEs. If there are rapid switches between large and small packet states during scheduling, the algorithm can swiftly adjust the MCS to meet service demands and improve user experience. Frequency Domain Adaptive Resource Allocation, accurate allocation. On live networks, small packet services account for a large proportion of the total. Frequent scheduling for small packet UEs places a lot of stress on frequency resources, causing frequent interruptions in data transmission for large packet UEs and reduced user perceived rates. Huawei's Frequency Domain Adaptive Resource Allocation algorithm for uplink boosting restricts frequency selective scheduling for small packet UEs while still guaranteeing their services. This releases more resources for large packet UEs, decreases the probability of their data packets becoming truncated, and boosts the overall average uplink throughput of a cell. Space Domain Adaptive Beam Pairing, accurate pairing. In a live network environment, relying only on correlations can lead to the pairing of UEs served by the same beam. This causes interlayer interference between UEs and degrades pairing performance. Huawei's Space Domain Adaptive Beam Pairing algorithm for uplink boosting addresses this issue by pairing UEs according to both correlations and beams. The algorithm predicts interlayer interference between UEs to be paired and preferentially selects UEs with low interference for pairing, thereby improving pairing performance. Power Domain Adaptive Power Control, accurate transmission. In real-world networks, UEs adjust their transmit power based only on individual service needs. Some small packet UEs may transmit data at excessively high power, causing strong interference to neighboring cells. To overcome this, Huawei's Power Domain Adaptive Power Control algorithm for uplink boosting identifies small packet UEs through their data volume. It then allocates more resources to these UEs according to the Shannon formula and adaptively adjusts their transmit power. This guarantees excellent user experience, reduces interference to neighboring cells, and improves the overall uplink user perceived rate. The uplink boosting solution has entered large-scale commercial use across various sites in Thailand, South Africa, and the Philippines. In medium and heavy load scenarios, this solution has achieved an increase of over 10% in uplink user perceived rates, allowing it to effectively meet the diverse service demands of the mobile AI era. That's all for Uplink Boosting. To learn more about Uplink Boosting, refer to the relevant document in the feature documentation of a specific version in the Wireless Product Documentation Center.